4.3, graphing proportional relationships. Pay attention to this key idea. It says when two quantities x and y are proportional, the relationship can be represented by direct variation equation y equals mx, where m is the constant of proportionality. So this only applies when x and y are proportional. And this constant of proportionality, we could say, is also known as, aka, the slope, which you should be familiar with what a slope is by now, or you might also call this the unit rate. So here's a graph that demonstrates what a proportional relationship looks like. And again, it's in this form, y equals mx, and it's a line with a slope of m. So the m is right there, that's the slope that passes through the origin. This part is super, super, super duper important. If you look at a graph of something and it does not go through the origin, it is definitely not proportional. So when we're talking about proportions, you just saw a graph and it said, is this proportional? Proportional. If it goes through the origin, you can say yes. Okay? If it does not, you have to say no. So let's go ahead and start looking at a graph. And I apologize for if your notes aren't as neatly arranged as these. I think the spacing got messed up on yours. So this says the cost y in dollars for x gigabytes of data on an internet plan is represented by this equation. Graph the equation and interpret the slope. So the first thing we want to do, I'm going to start getting our graph set up. Why don't you do that? Pause, put a title, put a label down here and a label over here, and then come back. So here's what I did. If you were confused on which one to put where, it says the cost y. So that's how you put the dollars on the y-axis, or x gigabytes, and that's how you need to put data or gigabytes on the x-axis. So here's our equation. What we've done before to graph is we have made an x and y table. So let's make a quick table here. So x, can x be negative values? Can we have negative gigabytes? No. So let's start with 0, maybe 1 and 2, and see if that's enough. Okay, you're plugging this into this equation for x. So 0 times 10 is 0, of course. Plug 1 in. 1 times 10 is 10. 2 times 10 is 20. And then you notice our graph is by ones. And a lot of times you'll have to change the graph. We'll give you a grid to get started with, but you need to make it work for you. So we can graph 0, 0, and then we need to graph 1, 10. You're like, okay, we can do that. And then 2, 20, and that's off our chart. So let's do something like maybe make this by 5. So that would be 5. There's 10, 15, 20, 25, 30, 35, 40. I think that's enough. So let's graph 1, 10. Let's graph 2, 20. You know what will come next? 3, 30, 4, 40. Those aren't in our table. We're going to connect those with a ray. So do the best that you can to make a straight line. You could use a ruler because that's hard for me on the screen. So there's a ray. It's going to continue going. The more points you make, the easier it is to make a line without a ruler. So there is our graph. And then it says, graph the equation, we did that, and interpret the slope. So listen up here. This is an important thing. When you interpret the slope, basically it means what's going on in real life, or what it is in this problem, I guess we would say. So what's in this situation? How about that? So what's in this situation? So from before, we have talked about that slope is our change in y over our change in x. So in this situation, our y value would be this, which is here, which is our money. So that's your money. And our x value is our theta. And it's always going to be that way on a graph. It's going to be your y over your x. So in real life situations with labels, this over this is going to be what your kind of label is for your slope. So what is our slope? From back up here, it said the slope was the m, and that would be in this position. Remember up above it said y equals mx, where m was our constant of proportionality. Sorry, I'm jumping here. I want to show you this again. Where m is the constant of proportionality, this is also known as the slope. Here it said it again. The graph is y equals mx, line with a slope of m. So the m is the slope. So in this situation, it's 10. Well, slope a lot of times is a fraction. How do you write 10 as a fraction? You're going to write 10 over 1. So still, in this situation, we want to interpret this. That means that it is 10 what? $10. So $10 per, fraction R means per. So $10 per one what? One data? That doesn't make sense. One what? Gigabyte. So $10 per gigabyte. That is interpreting the slope. We have to say what the slope means in this situation. Just telling me the slope is 10 is not enough. 10 what per what? So that's always going to be y-axis label over x-axis label. All right, let's go ahead and look at this next one. So it says here that the weight y of an object on Titan, so y is going to be Titan. I'm going to put a little y by that. Sometimes just make notes as you read, or come back and read it again and make your notes. One of Saturn's moons is proportional, okay, so that's an important word, proportional to the weight x of the object on Earth. So Earth is going to be the x. An object that weighs 105 pounds on Earth, so Earth was x, I'm going to label an x by that, would weigh 15 pounds on Titan. Titan was y, I will label a y by that. So like I said, either read the problem through once and then go back and label, or start labeling as you go, whatever works for you. So we're supposed to write an equation that represents this situation. We know it's proportional, that's what we're talking about. So the equation is going to be in that form that we just talked about. Y equals mx plus b. Oops, sorry, no plus b. That's for another day. Getting ahead of myself. So y equals mx. Sorry about that. Let's go back to here. So y equals mx. We need to find our m. You always want to know your slope. So what we can do is take the numbers that they gave us. Y is 15. We don't know m, but that is times x, which is 105. And then how do we find that? How do we solve for n? We're going to divide by 105, divide by 105. Those cancel. And if you reduce this side, you can actually divide both the top and bottom by 15, and that gives you 1/7 for your n. So then the way you write equations, that the m is the only thing you plug in at this point. So y is going to be y equals 1/7 x. That is your final equation that it was asking you to write here. Here's another way you could do that. I'm going to go switch colors. I would like for you to copy this down as well. But another way is we could have done an x and y table. Since it's proportional, we know it goes through 0, 0. They gave us this 105 for an x. They gave us this 15 for a y. Remember, we've talked about how n is delta y over delta x from a table. We've done this already. So what did y change by here? 15. What did x change by? 105. So again, reducing those, dividing top and bottom by 15, would also give us the 1/7. So you've got options. I'm going to give you a third option. So let's go different color. A third option, we said up there that this is called the constant of proportionality. So when it is proportional, all you have to do is the y over the x. So slope would equal y, which is 15, over x, which is 105, which again is 1/7. So you should have been writing this all down, and if you were writing all of that, please go back through and kind of put a little squiggle in here so you know that that was one way to do it, that's one way to do it, and that's one way to do it. So you've got 3 different methods for that. Okay, so then how much would a chunk of ice that weighs 3.5 pounds on Titan weigh? And again, what was Titan? Titan was y. So we're going to plug that in for y. So we use that equation that we wrote up top. Y equals 1/7 x. Put the 3.5 in for y. 1/7 x. How do you get rid of this 1/7? You divide. So you do 3.5 divided by 1/7. To divide by 1/7, you actually just multiply by 7, which will be 7/1. So you wind up with 24.5 equals x. So a chunk of ice that weighs 3.5 pounds on Titan would weigh 24.5 pounds on Earth. So this is why you might write an equation so that you can plug things in and solve it. Alright, let's move on to the next page. Go ahead and flip. And again, I'm sorry if your spacing is a little off. I think part of this was on your previous page. So we're comparing things, real life, got some ski lift going on here. Maybe Slope Dude's been out skiing, wants to get up the mountain quickly. The distance y in meters that a 4-person ski lift travels in x seconds is represented by the equation. The graph shows the distance that a 2-person ski lift travels. Actually, the graph also shows the distance that a 4-person ski lift travels. So, which ski lift is faster? Well, faster would mean it's going to get up the mountain first. So you want to gain more distance in a shorter time, or more height in a shorter time. So let's see if we can figure out which one has the higher constant of proportionality or slope. So let's just go slope. So the 2-person slope is going to, again, be the y over the x. So we want to pick a point. Okay, so on this 2-person, and I'm using blue, so on this 2-person, pick one of these points, like here. Okay, what is the y at this point is 8. What is the x at this point is 4. Okay, 8 divided by 4 is 2. And use red just for the 4-person. So for the 4-person, the constant of proportionality, or the y over x, and this doing y over x only works for slope when it's proportional. So keep that in mind. This isn't a new method for finding slope. This only works on proportional relationships. So on this one, let's pick any point. So we just want to pick one where it crosses perfectly through. How about right here? It looks like a good one. So what is the y here? The y is 10. What is the x? The x is 4. 4 goes into 10 2 times with 2/4 left over. So that's going to be 2 1/2. 2/4 is 1/2. So that one has a slope of 2.5. This one has a slope of 2. So it's asking us which is faster, and then that kind of ties into down here. What does the steepness of the slope have to do with the context of our problem? So this is kind of like that interpreting the slope. So remember slope up here. So slope is y over x. Up here, the y is distance over x is time. So what that would mean is that, since I'm using red, I'm going to go with the 4-person first. The 4-person means that they are going 2.5 distance, which is meters, 2.5 meters per 1 second. Okay, and the 2-person is going 2 meters per second.